Assalamualaikum and hello everyone. So in this video what we're going to look at is the last video about polarity itself. So let's look for the examples. So on your notes it will be on page 17 lah. Okay. So again this one is actually not available on your notes. Bolehlah write it down on a piece of paper or on post-it notes. Bolehlah kamu tampal. Okay. So let's look here. So again, for the case of our polarity ni, first thing first, what you have to do, what you have to know is actually the molecular geometry. So once you know the molecular geometry, you have to know the dipole moment. Okay, so the dipole moment tu, where the arrow tu must be towards more electronegative atom. So yang ini misalnya SNOF, increasing electronegativity. So yang ni F, chlorine, bromine, iodine ni. Okay, above ni baru kita increasing electronegativity for group 17. Okay, and then for the for if the molecule has hydrogen, which is the most electropositive, so that's where the bond the dipole moment should start, where that adalah tail of your arrow tu lah. So misalnya kita ada arrow kita kan, ni head dia, ni kita panggil tail dia. Okay. So previously I've mentioned about this one. So basically tapi adalah certain exception. Remember yang polar ni nanti Miss akan explain. Ada exception dekat sini which is square linear dengan square planar. Okay. So let's look here. Ini terus kita tengok example number 1. So how you should answer the question itself. Okay, example number 1. What we have here is my carbon dioxide. Okay, so remember my carbon dioxide ni, okay, dia ada it has only 1, 2 bonding pair. So even though it has 1, 2, 3, 4 bond, tapi dia adalah 2 bonding pair. So dia adalah yang ini is just a bit of revision. Ini saja jenis letak kat tepi. So dia adalah AB2, which is 2 bonding pair. So dia punya shape is linear. Okay. Okay, so for a given Lewis structure, for a given molecule, what you should do is actually your Lewis structure, and then you can determine what is your class, what is your electron pair geometry and molecular geometry. Then you should draw it. So for our carbon dioxide ni, okay. So right now how to draw the dipole moment? So remember dipole moment tu tengoklah berapa banyak bonding pair kita ada. So we have carbon oxygen 1. 1 bond kat sini, carbon dengan oksigen lagi 1 bonding pair. Okay, so how should we start our dipole moment? So kita akan buatlah. First, I'm gonna draw the first part ni. So here carbon dengan oksigen. So I'm just gonna draw an arrow. Okay, but towards which atom? Okay, towards kita tengok between my carbon dengan oksigen. Oksigen is more electronegative. So sepatutnya arrow kita towards situlah. So dekat sini, I'm gonna do kat sini towards oksigen. Make sure ada dia punya arrow, dia punya head dengan ada dia punya tail. Okay, so how about this pula, carbon oksigen ni? Pun sama juga. From the carbon to oksigen ni, kita buat satu. Kita punya head, jangan lupa kita punya tail ni. Starting from my carbon. So actually, bila dia adalah opposite sign, opposite direction, so we know lah what will happen is that mu dia is equal to 0. Sebab it is cancel out kan? So dia adalah equal to 0. So bila dia equal to 0, what does it mean? So we have to mention juga, it's not only the drawing of the shape and the dipole moment, we have to mention that the dipole moment, the dipole ataupun kat sini the dipoles itself cancel each other. So I'm just going to write cancel each other, and the overall dipole moment is 0. So, bila dia adalah 0, maka it is actually CO2 is a non-polar molecule. So, kita tengok kat sini lah. When it is equal to 0, the molecule is non-polar. Okay, so kita tengok dekat sini CCl4. Tak naklah CCl4 ni, I believe you could try yourself. Sebab dia adalah case identical terminal atom. Ini misalkan bagi soalan Google Form lah. Okay, example 3. Example 3 ni baru first time kita tengok when the central atom we have our lone pair. So sebenarnya ini just a bit of revision class dia. Okay, nitrogen ni ada 1, 2, 3. Ada 3 bonding pair. So dia adalah AB3. Ada berapa lone pair? Ada 1 lone pair. So AB3E. So it means ada 3 bonding pair, 1 lone pair. So dekat sini lah. Oh. So dekat sini. Oh. Okay, so how should we do the array itself? So tak kisah sekarang ni kita tengok. Kalau dia hydrogen dekat sini, between nitrogen dengan hydrogen. And then we know the nitrogen tu is considered as electronegative atom. And we know kalau hydrogen ni kan, dia adalah most electropositive kan. So dia, itu adalah where it should start. So contohnya dekat sini, arrow dia towards nitrogen. Okay, lepas tu dia start dekat situ. Okay, the same goes for the two hydrogen lagi. Okay, so what should we do? So what is the resultant dipole moment? So bila ada tiga-tiga ni, okay, yang lone pair ni kita ignore sahaja. So it means that the dipole moment is actually when we have a bond kan. So nitrogen ni, dia is bonded to 3 of the hydrogen je. So what is the resultant dipole moment? Kalau kat sini kita tengok. So contohnya kalau kamu nak buat ini miss, kita resultant dengan yang ini kan, maksud dia dekat atas. Lepas tu yang lagi satu ni pun dekat atas juga. So what happens is that the resultant dipole moment is actually upwards. Okay, so resultant dipole moment dia semua ke atas kan. So actually does it cancel each other ke tidak? It's not does not cancel each other off. So when it does not cancel each other off, so our mu is not equal to 0. Okay. So, the dipole moment, how to explain it? The dipole moment does not, the dipole do not cancel each other. Kan, sebab tak ada cancellation apa-apa pun. Sebab yang ini, contohnya if you take this one ke atas, this one pun ke atas juga. So, it is the same direction kan. So, does not cancel each other lah. Do not cancel each other and the overall dipole moment is not equal to 0. It's not, ataupun nak tulis not 0 pun boleh juga. So when it is not equal to 0, then it is the NH3 is a polar molecule. So NH3 is polar molecule. Okay. So kat sini, again, kalau unsymmetry, where it means the central atom has lone pair, usually dia adalah polar lah. Ada exception, square planar dengan linear. Lama, copy paste je lah sini So kita tengok pula lagi H2O. Okay, H2O ni pun ada lone pair juga. So again, how to draw the dipole moment? Remember towards more electronegative, which is towards oxygen lah dalam case ni. So kita ada dua bond kan. So ada dua arrow je lah. So satu ni from sini pula. From hydrogen towards oxygen, sebab nak pergi, it means that electron ni suka pergi dekat oxygen lagi. Ikutlah nak buat yang delta negatif tu nak ke tak nak pun boleh juga. Paling penting ada arrow ni. So what happened here is that, okay, so this is my dipole moment. My resultant dipole moment nanti dia akan jadi ke atas lah. It will not be cancelled out. So the resultant dipole moment here will be upward. So what will happen is that our mu is not equal to 0. So sama juga macam tadi, how do we explain it? So kita katalah the dipole do not cancel each other and the overall dipole moment is not equal to 0. Hence H2O is a polar molecule. Okay. So itu adalah untuk this part, unsymmetry. Okay, so let's look here for CH₃Cl ni. Okay, dia adalah tetrahedral, where the shape is actually symmetry lah kan. Okay, tapi dia ada, we have 3 hydrogen, satu chlorine. So dia lain sikit. So how should we draw the arrow? So again, kalau ada hydrogen, it's starting from our hydrogen. So ada 3 lah. Okay, so maknanya from hydrogen start pergi kepada carbon. Sebab it is the most electropositive kan. So start pada situ lah. Okay, then between carbon dengan chlorine, actually, between carbon dengan chlorine is more electronegative. Okay, sebab chlorine is one more electron kan. Sebenarnya between carbon dengan chlorine is more electronegative. So, kat sini arrow dia macam mana? Arrow dia akan ke atas lah. From carbon to chlorine. Okay, so what happened here? Sini, dia punya resultant dipole moment dia. The resultant dipole moment dia is actually upwards. Okay, and then yang merah tu pun sama juga. So, it does not cancel each other even though dia adalah tetrahedral symmetry shape. Tapi sebab lain kan dia punya atom, so macam itulah. So, what would happen here, dia adalah the dipole moment. So, kita kena tulis ada kat sini. Mu dia is not equal to 0. Okay, so the dipoles do not cancel each other and the overall dipole moment is not equal to 0. Hence, CH₃Cl3 is a polar molecule. Okay. Sebab itulah, kalau tak nak tengok ni pun tak apa. Sebenarnya, based on the shape tu, kamu buatlah arrow kamu ke mana. SO2, I believe you could try yourself. Okay. Yang example on page 17 lah, on your notes. 18 lah, betul lah, 18. Ke 17, tak lah. Tapi yang page ni lah Okay, so yang ini actually, this is actually all the answer yang kamu dah buat dekat sini lah. Example on page 15 ni. Ingat tak ini? Okay, so ada yang Miss dah buat. So, kiranya ni jawapan dia lah. Kalau kamu dah jawab Google Form tu, sepatutnya kamu tahu this is actually the answer. Okay, so sekarang ni Miss nak buat. So, yang ini boleh buat sendiri. Okay, so yang ni, XeF₄. Okay. So, sebab before this I have mentioned that unsymmetry ni, dia kata semua adalah polar molecule kan. Tapi Miss kata ada exception. Okay, kenapa ada exception? Okay, so contohnya kita tengok XeF₄. So, I'm just gonna draw kat sini XeF₄. Okay, so what happened here is actually, remember, kiranya if anything memang more electropositive tu senof kan. Senof. So, kira fluorine is more electronegative. So, semua arrow ni kita nak buat kepada fluorine. So, ada 4 bond kan? 1, 2, 3, 4. So, what happened here is that, okay, so kita adalah 1, 2, 3, 4 dipole moment kan. So, the resultant dipole moment. So, bila Miss nak resultantkan dipole moment, it's actually, okay. So, Miss akan combinekan this one, this part, dengan this part. Okay. Okay. So, for this dipole moment, the resultant dipole moment for this is actually to your right. Betul, right? To your right. Okay. Kalau yang ni, the resultant dipole moment ni is to your left. So, once ada satu ni to your right, satu ni to your left. So, what will happen is that it will cancel each other. So, what happen is that we have to write down lah. Mu is equal to 0. So, we have to mention that the dipole moment if you don't want to write down overall ni pun boleh je tulis balik. So, kita buatlah. So, even though tadi kita ada cakap, satulah Miss kata ada exception. Bukan semua yang ada lone pair. Unsymmetry ni lone pair on the central atom tu semuanya non-polar. Semuanya polar, sorry. So, ada exception. Okay, ada lagi satu, ICl₂- ni. So, ICl₂- ni, shape dia linear. So, again, kalau contohnya dari sini kan, between iodine dengan chlorine. Chlorine is more electronegative. So, between iodine dengan chlorine ni, sebenarnya chlorine is more electronegative. So, buatlah arrow towards chlorine. So, what happen here is that sebenarnya it will be cancel out sebab the opposite direction kan. So, we have to write it down lah. Yang lain-lain ni, I believe you could try yourself. Nanti kalau Miss rajin, Miss ada bagi lagi example lebih lagi. So, detect whether it's polar ke non-polar. Okay, example J dengan K ni, you should try yourself. So, ClF₄-. So, before anything, apa yang kita nak buat? So, again, first thing first, you have to do the Lewis structure, then your class, then the electron pair geometry dengan molecular geometry. Okay, next, determine dia ada polar ke non-polar. Polar tu, yang polar non-polar bond tu, same atom ke different atom. So, kalau dah different atom, macam contoh semua ni banyak case kan different atom kan. Carbon oxygen, bond tu. So, dia adalah polar bond, barulah kita boleh draw dipole moment. So, nanti determine. Yang ni tak boleh, misalkan buat step by step untuk kamu. So, that's actually the end of our polarity.